so little introduction here to the big four kinematic equations. These are the crux of the constant acceleration model. As such, right, these equations are only applicable if acceleration is constant over the time interval in question, right? So if the acceleration is changing, you cannot use these equations, all right? Remember that. You need a constant acceleration, right? That means that the velocity has a linear slope, right? It's not curved or anything like that. It's not changing. Just to review some variables that you'll see in these equations, right? I'm using slightly different conventions for final and initial velocity. Remember, we sometimes use v sub f for final velocity. In this case, I'm just going to have it be v, and I'm going to use v naught, right? For initial velocity, we sometimes use v sub I, right? Those are the same. Again, delta x is displacement, t is time, right? Time since the start of the interval, right? What I mean by that is if something's traveling at a certain velocity and we say that the interval that we're concerned with is from 2 seconds to 4 seconds, right? Your time value isn't going to be 4 seconds, it'll be 2 seconds because that's the amount of time that passed between when you started your observations to when it ended. Most of the time we'll start our intervals at 0, so the time that it ends will be the time that you can plug in. But just keep that in mind, it can trip some people up. And A is acceleration. All right, so I ended the last video looking at these two of the big four that we know already, right? They are pretty clearly derived from some equations that we've already seen, and also from graphs, right? From calculating, for this one, right, calculating the displacement as the area under the velocity time curve, right? This is that sort of put into mathematical form. The other two, so I'm going to go ahead and see if I can just drag these down there. The other two equations that we will be adding on to these two are going to be less intuitive. They're really hard to derive, but you're just going to have to trust me that they're true. And there we go. And use them as shortcuts, right? So the next two equations are really hard to see where they come from, but they're great shortcuts for solving word problems, which is why we're going to include them. All right, come on, computer. There we go. So, right, we've walked through these two, pretty clear with what's going on here. The third kinematic equation, not going to show you how to derive this one, but one that should be in your notes. And you can use it on word problems. You may have to memorize it, right? It could be helpful for tests and quizzes and things like that, right? It's solving for displacement, and you use, right, the velocity final minus, plus velocity initial, v naught, divided by 2. And then all of that times the time. Okay, that's going to also give you displacement. And I'm not going to tell you where this comes from, but it does work, so you can use it to solve for displacement anytime the acceleration is constant. And the fourth equation is one in which you can solve for just say velocity, right? Remember, this v is velocity final. I'm not going to write the final. Velocity final squared times, velocity final squared equals velocity initial squared plus 2 acceleration times the change in position. All right, so these two, kind of hard to see where they come from. The derivation of these two is rather messy, so I'm not going to bother you with them, but you should put it in your notes because they can be really helpful for solving word problems like this one, right? A dog runs at 7 meters per second in the positive direction. It accelerates at 1.22 meters per second squared for 2 seconds. What's the dog's velocity after those 2 seconds? So we can use one of these equations to solve this problem. The question is, which one is appropriate? In order to decide which one is appropriate, I like to go through and label what's missing from each equation, right? Of these variables that we have here, there's something missing from each of these equations, right? In this case, displacement doesn't appear anywhere. So that's the first equation. Displacement is missing from the first equation. In the second equation, right, we've got time, acceleration, initial velocity. We're missing velocity, right? The final velocity. And the third one, we're missing acceleration. And the fourth one, we are missing time. So if we're trying to solve for acceleration, right, equation number 3 is not going to be helpful, right, because there's no acceleration involved in there. We could use any of the other ones, right, but we couldn't use number 3, right? Same thing with displacement, right? If we wanted to solve for displacement, number 1 is not going to be helpful, all right? So by keeping these straight, you can figure out which one is best to use given the problem that you're trying to solve. So let's go ahead and walk through this problem here and just label what values we have, right? We have a dog running at 7 meters per second, okay? That's some velocity, not sure yet whether it's our initial velocity or our final velocity. It's 7 meters per second, and that's in the positive direction. Okay. We're then told it accelerates at 1.22 meters per second squared. That's pretty easy. That's our acceleration. Negative 1.22 meters per second squared. Right, for 2 seconds, we're assuming the start of that interval is 0, so it's doing that for 2 seconds is our time, right? And then we're asked for the velocity after those 2 seconds, right? So we have a starting velocity and we want to know the velocity after those 2 seconds, right? So now I know that this is my initial velocity and I would like to solve for my final velocity. All right, so now we have our given variables in this word problem. What's missing here, right, is displacement. So of the equations, I'm not going to want to use, I'm not going to want to use any of the equations that have displacement in them, right? Because I don't have any value for that. And I'm also not concerned with it, right? They haven't asked me to solve for the displacement, and I don't have a value there. So I don't want to use 2, 3, or 4, right? Because this displacement variable shows up there. That leaves me with number 1, right? Oh, and how convenient, right? It's already solving for my final velocity. So now I can just plug in all of my values, right, for my equation number 1, which is so I'm going to have positive 7 meters per second, careful to put my units in there, plus negative 1.22 meters per second squared times 2 seconds. Right, so that's going to be 7 meters per second minus 2.44 meters per second, right? That means my final velocity is going to be, some mental math here, 6.56, I believe, meters per second. Okay, so just by selecting the correct equation, this starts to be simplified, right? Let's try this one more time. So now we have a dog running with a velocity of 5 meters per second, right? We don't know necessarily if that's our final velocity or our initial velocity. We'll have to wait to find out, but positive 5 meters per second. No, this is wrong. Hold on. The wording's wrong. Velocity. There we go. After 2 seconds, it has a velocity of positive 1 meter or positive 11 meters per second. How far did the dog run during those 2 seconds? Okay, so we can see that we start with a velocity of 5 meters per second and we end with a velocity of 11 meters per second. So I now know that this is my initial velocity and 11 meters per second is my final velocity. We're given time, right? We're told that the time is 2 seconds, right? And we want to know how far the dog ran, right? Or its change in position, right? Change in position is what we're looking for here. We're looking for an answer that's in meters. We're missing acceleration right from here. So we want to find an equation that doesn't have acceleration. Right, this one is missing acceleration. So it looks like number 3 is going to be our best bet, right? And number 3 says that displacement equals velocity final plus velocity initial over 2 times time. Okay, so now we just have to plug and chug these numbers. 5 meters per second plus 11 meters per second over 2 times 2 seconds. The change in position equals 16 meters. Okay, so these equations, right, they make your life super easy as long as you can figure out the correct one to use. I would recommend copying these equations into your notebook with this little note of what's missing, right? If you can figure out what's missing and you can figure out what's missing from your word problem, it's pretty easy to pick which equation is best to use. All right, don't forget to do your finding the slope worksheet, as that is also part of your homework, and I'll see you next class.